Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for TEAS. We have been solving TEAS problems, TEAS math problems out of this book here, the TEAS Study Guide, version 7, 2025. If you do not own this book already, purchase one immediately. You're going to need it. Always make sure that this book is in front of you when we're working together. Today is our lesson number 23. Today we'll start a new topic of ratios and proportions. Ratios and proportions. Ratios and proportions are not one and the same thing. They are two different concepts. Ratios are different than proportions. Today we'll deal with a couple of problems dealing with ratios, and tomorrow we'll learn the concept of proportions, and we'll do a couple of problems dealing with the concept of proportions. Let's learn ratios today. Ratios deal with like things, and by like things we mean the things that are similar. Things that can be added or subtracted. For example, here we have a problem dealing with males and females. Once we figure out how many males there are, how many females there are, we can most certainly ask ourselves, so how many total people are there? We can add males and females. We can add blue candies and red candies. We can add red cars and blue cars in the parking lot and ask ourselves how many total cars we have. We can add students and teachers to find out how many people there are in the building. Those are called ratios. The things that can be very easily added. Tomorrow we'll deal with proportions, where we'll come across things that cannot be added. It will make no sense to add them. We'll see that tomorrow when we get to them. But those are proportions. Let's look at this problem. Here we are told that we have a factory, and we are told that in this factory the ratio of males to females is 3:8. If there are 24 females, we are told, if there are 24 females, the question is how many males there are. Well, it's a ratio problem. It's the ratios of two things, males and females. Now, whether you set it up as males over females or females over males, it makes no difference. You can set it up any way you like. Do you understand? Trust me, either way it's a lot of fun. Let's do males over females. So, in a factory, the ratio of males to females, the reason I did that this way is because this is how it's mentioned in the problem. If the problem had said the ratio that the ratio of female to male is such and such, then you would have put whichever one you see first, you set it up like that. That way you can't go wrong. Here we have males to females. Ratio is 3:8. 3:8. And the question is, if there are 24 females, so you have to keep track of your work. If there are 24 females, we're talking about females that are in the bottom, the question is, how many males do we have? Well, it's very straightforward. This is 8 and this is 24. You have to ask yourself, 24 is what multiple of 8? In other words, what do we need to multiply 8 by to make it 24? The answer is 3. The answer is 3, which means we scale up this quantity. This is called scaling. We scale up this quantity, this ratio rather. We scale up this ratio by a factor of 3. And now we have 8 times 3, which is 24. Since the bottom is 24, since this bottom is same as that bottom, this top has to be same as that bottom. In other words, there must be 9 females. There are 9 females, or rather 9 males and 24 females. Do you understand? For a total of 33 employees. You see, we can add them. If there are 33 employees, we can add them. We can subtract one from the other because they are like things. They are similar things. Let's do one more. Here's another question. We have a box, we are told. In a box, the ratio of red marbles to blue marbles is 4:5. Here's the question. The question is, if there are 24 red marbles, how many blue marbles? Again, since the question says in a box the ratio of red marbles to blue marbles is such and such, since red is mentioned first, I'm going to put the red on the top and the blue. Always keep it like this, keep it systematic. Ratio of red to blue is 4 to 5. 4 to 5. Because if you don't follow this order, and if you put blue on the top and red on the bottom, but you forget to switch this thing, then it's a problem. So don't make it unnecessarily complicated. Write them in the order that they appear. Red to blue is 4 to 5. We are told that there are 24 red marbles. This is where you have to pay attention. What is mentioned here, red is mentioned here, 24 red marbles. So on the top it goes 24. The question is how many blue marbles do we have? So we need to scale up this ratio. We need to scale this ratio up by a factor of, well, that's what we have to figure out, by a factor of what? In other words, what do we need to multiply 4 by to make it 24? 24, 4 times what number is going to get 24? In other words, 24 divided by 4 is 6. So you have to scale it up by a factor of 6, by a multiple of 6. There we go, we're done. So now 4 times 6 is 24, which means whatever is in the bottom, that's the x. The x is 30. We must have 30 blue marbles. 30 blue marbles and 24 red marbles. Tomorrow we'll do a couple of problems dealing with the concept of proportions, because that's what it says. It says ratios and proportions. This is a ratio. What the bloody hell is a proportion? Well, we'll learn it tomorrow, okay? Bye now.